Whatever reality is, it's not what you see. What you see is just an adaptive fiction. The first time I thought it might be possible that we're not seeing the truth was in 1986. It was from some mathematics we were doing. And when that hit me, it hit me like a ton of bricks. I had to sit down. It was scary. It was really a shock to the system. They're not there to show you the truth. In fact, the way I think about it is they're there to hide the truth because the truth is too complicated.
Emotion became a feeling. No phrase that our lips can frame is so devoid of apprehensible meaning. William James, The Principles of Psychology. We live convinced that our senses offer a reliable window into the world, that seeing is believing, that what we touch, smell, and taste exists, whether or not we're paying attention to it. But that certainty collapses under scrutiny. Donald Hoffman warns us, our senses weren't designed to show us the truth, but to keep us alive. And the difference between those two things is vast. This is not merely a philosophical idea. It's an evolutionary necessity. Natural selection doesn't care about truth. It rewards behavior that increases chances of survival and reproduction. If perceiving a distorted version of reality helps an organism evade predators, find food, or attract a mate, then evolution will favor that distortion. From this perspective, our senses are less like windows to the world and more like filters, tuned not for accuracy, but for utility. Humans perceive only a sliver of the electromagnetic spectrum. We don't see ultraviolet, infrared, or feel magnetic fields. Yet bees, snakes, elephants, and sharks can. What we call reality is, at best, an adaptive interface, like a computer screen. Useful, yes, but not a faithful representation of the system it hides. But even knowing this, we remain trapped in the illusion. If you see a red tomato on a table and then close your eyes, you likely believe the tomato is still there. You can reach out, smell it, or ask someone else to confirm it. And if you do, your conclusion will be firm. Yes, it's there. What we don't consider is that all that evidence, even when it seems objective, is built upon the same perceptual mechanisms that are, by nature, deceptive. So could it be that the tomato isn't really there when you're not looking? Could your mind be crafting a narrative that's as convincing as it is false? To begin to glimpse this possibility, Hoffman turns to a classic optical illusion, the Necker cube. Observe and focus on this figure for a few seconds. Pause the video if you need to. This seemingly simple image reveals an unsettling phenomenon. If you look closely, you'll see a three-dimensional cube. But over time, your perception shifts. The cube flips. The back becomes the front, and the front becomes the back. You can never see both interpretations at once. Your mind picks one, projects it, and then changes its mind. This spontaneous switch reveals a powerful fact about perception. It is not passive reception, but active construction. Your brain is constantly interpreting limited data and forming a coherent story, often without your awareness. The cube hasn't changed, but your internal model has. What feels like seeing is often just guessing, an elegant evolutionary shortcut that trades precision for speed and survival. Yet the drawing, the physical stimulus, hasn't changed at all. Here, something crucial happens. What you experience as real isn't what's out there, but what your brain interprets. And when you stop looking, that perceptual construction dissolves. The same happens with the tomato and with everything else. This phenomenon has deceived humanity for centuries. There was a time when people believed the earth was flat, because that's what the eye told them. Later, the geocentric model placed the earth at the center of the universe, unmoving while everything else orbited around it. And for over 1,000 years, The Catholic Church held on to this idea as unquestionable, supported by both literal interpretation of Scripture and sensory perception. Galileo was one of the first to break with this illusion, proposing that the Earth orbits the Sun, and for that he was condemned. But the error wasn't only theological, it was perceptual. As the philosopher Ludwig Wittgenstein explained to Elizabeth Anscombe when she told him it looked like the Sun moves around the Earth, he replied with a disarming question: "And how would it look if the Earth actually moved?" The phrase revealed that many of our beliefs about what seems real have no critical foundation. We cling to what we see, even if it's a construction. This idea becomes especially unsettling when we realize that evolution doesn't reward those who perceive the truth, but those who perceive what's useful for survival. Donald Hoffman challenges us to accept that we may have misunderstood our most basic experience, looking at the world and assuming we're seeing it as it is. It must be confessed, however, that perception and that which depends upon it are inexplicable by mechanical causes, that is to say, by figures and motions. Supposing that there were a machine whose structure produced thought, sensation, and perception, we could conceive of it as increased in size with the same proportions until one was able to enter into its interior as he would into a mill. Now, on going into it, he would find only pieces working upon one another, but never would he find anything to explain perception. Gottfried Leibniz. When philosopher and mathematician Gottfried Leibniz imagined stepping inside a machine capable of thinking and perceiving, he envisioned gears, levers, and moving parts. But no matter how closely one examined those mechanisms, nothing would reveal the essence of what we call perception. There would be no pain, no color, no fear, only physical structures in motion. His conclusion was radical. Perception could not be explained by mechanical causes. Centuries later, neuroscience still faces the same paradox. Cognitive scientist Donald Hoffman, drawing from evolutionary theory, suggests that the mistake lies in assuming that our senses reveal the truth. According to his research, what we experience as reality is not an objective world, but rather an interface evolved to maximize survival. Think of your computer screen. You see icons, folders, documents, a bin. These are flat symbols. They have no depth, no mass, no actual connection to the processes running behind them. And yet, they work. You can drag a file, delete it, or open it, without ever knowing how the internal system really functions. Hoffman compares this user interface to our perceptual experience. We see what we need to act effectively, not what truly exists. And this isn't just a provocative metaphor. Formal evolutionary models and simulations suggest something quite startling. Organisms that perceive reality as it is tend to lose the evolutionary race. Those that perceive only what's useful, what enhances survival and reproduction, thrive. The logic is brutal. Every neuron consumes energy. Seeing more than necessary becomes an evolutionary liability. From this point of view, perception is not a window to the truth. It's an adaptive strategy. Color, shape, space, and time might not exist at all in the way we experience them. They are merely tools. Efficient, stripped-down representations coded to suit our survival. Just like the bin icon on your screen isn't cylindrical or smelly, yet you know what it does. This notion is as unsettling as it is liberating. Our senses aren't lying in a moral sense, they're shielding us. They hide complexity we don't need to interact with. What we take to be a solid, stable external world might just be a graphical user interface generated in real time by our consciousness, an interface shaped over millions of years by natural selection. Our experience of reality, then, is not a passive reflection, but an active construction. The brain builds a model, moment by moment, that serves our goals. Navigating, avoiding danger, finding food, connecting with others. But this model is not neutral. It's shaped by evolutionary pressure, cultural context, and individual history. That means what one person sees might be invisible to another, not due to blindness, but because each mind renders its own useful version of the world. So why do we still insist we're seeing the world as it is? Because intuition, like perception, evolved to favor usefulness over truth. The brain must make quick decisions, not philosophies about the ontological status of the objects in view. Psychology offers a telling example. Participants are asked to fix a candle to a wall using a box of drawing pins and some matches. Most people fail, not realizing that the box itself can serve as a platform. Why? Because they implicitly treat the box as a container, not as a potential tool. Their assumption of fixed function blocks creative insight, and that's exactly how perception works. We assume that what we see is what something is. Even Galileo, centuries ago, hinted at this illusion. He noted that qualities like taste and color don't belong to objects, but to the mind. If no one is there to perceive them, there is no taste, no color, no pain, and perhaps no world at all. Donald Hoffman is not saying that nothing exists. He is saying that whatever does exist bears no resemblance to what we perceive. And in evolutionary terms, that's not a glitch. It's precisely how things are meant to be. Actually, the evidence as we see it favors the view that the minor hemisphere is very conscious indeed. Roger Sperry. Inside a single skull, two minds can coexist. This isn't a metaphor, but a reality documented by neuroscience. Two conscious entities, each with distinct desires, beliefs, and intentions, can live within one brain. What we call the self can dissolve with a single surgical cut. The procedure is called a callosotomy. It severs the corpus callosum, the vast bundle of neural fibers connecting the left and right hemispheres of the brain. Originally developed to treat severe epilepsy, it yielded results no one anticipated. In the 1960s, neurosurgeons Joseph Bogan and Philip Vogel performed the first surgeries. What followed stunned the scientific world. With the hemispheres disconnected, patients began displaying behaviors that contradicted themselves. Roger Sperry, who studied these cases in detail, observed that each hemisphere seemed to function with a mind of its own. One of the most dramatic examples was a man named Bill Jenkins. His hands fought with each other. One hand tried to button his shirt, the other unbuttoned it. One tried to turn a page, the other shut the book. This was a literal internal conflict, visible, measurable. These patients revealed a mental architecture no one had imagined. In one of the most iconic experiments, the word key was shown to the left visual field, processed by the right hemisphere, and ring to the right visual field, handled by the left hemisphere. The patient was then asked to draw what he saw. Using his left hand, governed by the right hemisphere, he drew a key. When asked to explain what he had drawn, the left hemisphere, responsible for language, was confused. It hadn't seen the word key. But once the picture was complete, something remarkable happened. The patient recognized the drawing as a key ring. Two separate processes had converged on a shared, functional interpretation, without direct communication between hemispheres. This phenomenon also raises deep philosophical and ethical questions. If two distinct minds can exist within the same brain, what does that mean for responsibility, for identity, for the idea of free will? When one hemisphere commits an act the other disagrees with, which is the true self? Some researchers have even speculated whether split-brain patients might qualify as two individuals in one body, each with its own agency and experience. While this remains controversial, it forces us to confront how fragile and constructed our sense of unity truly is. In the end, the split-brain experiments don't just reveal something about patients, they reveal something about all of us, that perhaps our own inner consistency is a delicate performance, held together by a whisper-thin thread of connectivity. Some cases were even more unsettling. Certain patients demonstrated opposing religious beliefs in each hemisphere. One side claimed to believe in God, the other denied it. This division wasn't just behavioral, it was ideological. Each hemisphere seemed to maintain its own worldview. Vilayana S. Ramachandran, a leading researcher in consciousness, argued that this wasn't a defect, it was a revelation. The unified consistent self, with a singular will and identity, is a functional fiction. So long as the hemispheres communicate, this illusion holds. But when they're cut apart, the truth is exposed. The mind can divide into two autonomous entities sharing the same body. Here, the Necker cube becomes more than a visual illusion. It transforms into a cognitive metaphor, a shape that can be perceived from two alternating perspectives, but never both at once. This is how consciousness operates. When the system remains unified, one perspective dominates, but when the connection breaks, both perspectives emerge, two minds observing each other in silence. This doesn't imply madness. It challenges the evolutionary narrative of a unified personal identity. If our senses don't show us objective reality, as we've already discussed, then why assume that the perceiver is a singular, cohesive being? All evidence suggests the self is a result of constant negotiation between specialized brain networks. And when that dialogue is interrupted, coherence fractures. The most unsettling part isn't that this split can occur, but that our sense of mental stability relies on such a fragile biological thread. Perhaps we don't inhabit a single mind. Perhaps we live within an ongoing negotiation, an uneasy truce between internal voices that, even if we never hear them clash, may be constantly at odds. You are nothing but a pack of neurons. Francis Crick. Francis Crick, one of the discoverers of DNA, eventually left the field of genetics to confront a far more baffling frontier: consciousness. His astonishing hypothesis proposed that everything we feel or think, joy, sorrow, love, or faith, is a direct result of brain activity. No soul, no mystery, just neurons firing in synchrony. And yet, despite decades of research, science still cannot explain what consciousness truly is. We've mapped brain regions tied to perception, language, and emotion. We can record the electrical impulses accompanying each thought. But none of this tells us why there is an inner experience, why pain hurts, or how matter produces subjectivity. Crick believed that, just as DNA solved the riddle of heredity, neuroscience would one day unravel the mystery of the mind. But the brain doesn't behave like a strand of chemical instructions. Attempts to decode consciousness using the same tools that crack the genetic code face an invisible wall. Conscious experience cannot be reduced to a diagram of neural connections. Contemporary models, such as theories of emergence or brain monitoring, describe processes, but don't explain them. They claim consciousness arises from complexity without detailing the mechanism. It's like saying a melody appears because there are enough notes. True, but insufficient. Some suggest that we may be looking in the wrong place altogether. Rather than dissecting the brain further, we might need to shift our frame of inquiry, asking not how neurons create experience, but whether experience is a fundamental property of reality itself. This controversial perspective, known as panpsychism, proposes that consciousness might exist in some rudimentary form in all matter. It reframes the question entirely, not how the brain generates mind, but how mind manifests through the brain. More than a century ago, Sigmund Freud sensed something similar. His idea of the unconscious was an early attempt to probe what escapes rational awareness. Though lacking empirical evidence, Freud's proposal suggested that a vital part of mental life lies beyond introspection. Modern neuroscience, armed with advanced technology, confronts the same barrier. It can watch the brain work, but it cannot peer into the experience itself. This line of thinking has gained attention among philosophers and cognitive scientists alike. It doesn't solve the mystery, but it offers a radically different lens. Perhaps, just as quantum physics reshaped our understanding of matter, a new paradigm is needed to grasp the nature of mind. Until then, the hard problem of consciousness remains unsolved. Not due to lack of data, but because we may be asking questions our current tools are unequipped to answer. Noam Chomsky has also warned against extreme reductionism. While the brain is undoubtedly a biological machine, he argues that its products, language, imagination, consciousness, may exceed the bounds of the purely physical. The mind, when it turns inward, seems to encounter the edges of its own capacity. Some researchers have gone further, suggesting that this boundary may be absolute. Perhaps consciousness is something the brain can produce, but never fully grasp, like an eye that sees everything but itself. The current failure of neuroscience is not a sign of defeat, but of humility. Even in an age of brain scans and artificial intelligence, we find ourselves face to face with a mystery as ancient as it is essential. Consciousness remains a fire burning within us, impossible to dissect, but undeniably real. Neuroscience has spent decades studying the neural correlates of consciousness, specific patterns of brain activity that accompany our subjective experiences. The goal is clear: to pinpoint where and how those experiences occur inside the brain. One of the pioneers in this pursuit was Wilder Penfield, a Canadian neurosurgeon who operated on epileptic patients while they were awake. During surgery, he electrically stimulated various regions of the brain. The results were astonishing. Patients reported smells, vivid scenes, emotions, memories, and even physical sensations, all triggered by a simple electric current. These findings marked a turning point. Consciousness seemed to have precise coordinates in the brain, as if every element of our experience could be activated from a specific point on the cortex. Decades later, more modern techniques such as transcranial magnetic stimulation, TMS, have replicated these effects in controlled settings. By delivering magnetic pulses to the brain's V4 visual area, responsible for processing color, researchers can switch color perception on or off. A condition known as hemiachromatopsia, or the loss of color perception in one half of the visual field, also naturally arises when this region is damaged. In such cases, the visual world becomes split. One half remains vibrant, the other turns gray. Another striking example is the postcentral gyrus, the region responsible for processing touch. Direct stimulation of this area produces sensations such as tingling, pressure, or phantom touches on specific parts of the body. These aren't imagined, they are felt by the patient as real, with full conviction. Electrical activation evokes experience without any external trigger. All of this supports the idea that certain contents of consciousness can be mapped in the brain. But mapping is not the same as explaining. Knowing that a region lights up when we feel fear or joy is not the same as understanding why those feelings arise. This is where the real challenge lies. Correlation does not imply causation. A brain region may activate during an experience, but that doesn't prove it caused the experience. It may be participating, reflecting, or even responding to a larger process we still don't grasp. At this stage, neuroscience continues to chart the terrain, but it hasn't yet found the source. This challenge has prompted some neuroscientists to rethink what they're really observing. If brain activity is not the direct source of consciousness, could it be a reflection of deeper processes we haven't yet conceptualized? Perhaps what we see in brain scans are shadows, biological footprints left by something far more elusive. Consider dreams. While asleep, with no external stimuli, the brain generates entire worlds. These dream experiences can be vivid, emotional, and coherent, even though no real inputs are involved. How can grey matter alone produce such immersive simulations? Some researchers propose that consciousness might not be tied to a specific structure, but to patterns, flows of information across networks. Still, this only shifts the mystery. What transforms data into experience? The more we probe, the clearer it becomes that we're missing a fundamental piece. Consciousness may not simply arise from the brain, but instead interact with it in ways that defy current models. Until we solve that puzzle, the true origin of awareness remains unknown. Moreover, some illusions induced through brain stimulation suggest that certain aspects of consciousness can be artificially replicated, though not necessarily fully. Is a memory triggered by an electrode the same as one recalled naturally? Is a pain induced by electricity emotionally equivalent to one caused by injury? These questions point to a crucial line of inquiry, not just where experiences happen, but how they become meaningful for the person who lives them. In the meantime, the search continues. Science is making progress in identifying increasingly precise brain correlations. But for now, pinpointing where consciousness shows up has not revealed what causes it, nor how it begins. The mystery remains right at the core of what we feel. For centuries, the soul was considered intangible, beyond manipulation or interference. Today, however, neuroscience proposes something radically different. Emotions, traumas, and memories can be edited. Psychologist Merrill Kint has developed a therapy that targets the neural correlates of emotional consciousness. The procedure is precise. A traumatic memory is first recalled in a safe, controlled environment. At the moment when the memory becomes active and emotionally vulnerable, propranolol is administered, a drug that blocks the emotional reconsolidation process. The result? The memory remains, but the fear, anguish, or anxiety attached to it vanishes. This approach doesn't erase memory itself. It erases the emotion tied to it. For those suffering from phobias, post-traumatic stress, or debilitating recollections, this method offers new hope. Kind has documented several cases in which a single session has transformed years of suffering into emotional calm. Beyond pharmaceuticals, science is exploring even finer tools. Optogenetics merges neuroscience and bioengineering. allowing neurons to be controlled by light. Through genetic engineering, certain brain cells are made responsive to optical stimulation. This enables researchers to activate or suppress memories, emotions, and sensations with a flash of light. Like flipping a neurological switch, researcher Christine Denny has used this technology with genetically modified mice. In one striking study, mice trained to associate a space with pleasant experiences were returned to that space later on. By illuminating specific neurons tied to the happy memory, the mice displayed signs of emotional comfort. In essence, a positive experience was reactivated artificially. Recent advancements in neurofeedback also show promise in this domain. By training individuals to alter their brainwaves through real-time monitoring, researchers can guide patients to achieve emotional stability and reduce symptoms of anxiety or trauma. Unlike pharmacological methods, neurofeedback encourages internal self-regulation, making the patient an active participant in their cognitive recalibration. Though the technique is still developing, its non-invasive nature and empowering effects suggest it could complement other forms of emotional editing in the future. These discoveries hint at the future of emotional precision medicine. The goal is not simply to dull pain, but to reintroduce joy, peace, or motivation in those who've lost access to those emotional states. Still, not all paths are clear. Emotional editing raises ethical questions. What happens to the authenticity of a memory when its emotional content is altered? Are we healing the person or rewriting their identity? Equally intriguing is the emerging role of virtual reality in emotional modulation. Immersive environments are being used to recreate specific memories or simulate therapeutic encounters, allowing patients to confront and reshape their emotional responses in real time. This controlled exposure can desensitize traumatic triggers and reinforce positive associations. Combined with pharmacological or neural interventions, VR could become a powerful tool in rewriting how emotions are encoded and recalled. The fusion of digital and biological therapies marks a turning point in how we understand and transform consciousness. Unlike electroshock therapy or broad-acting psychotropic drugs, these new treatments target specific circuits of emotional consciousness. The aim is no longer to silence the system, but to fine-tune its contents. The patient is not anesthetized, they are reprogrammed. For now, emotional editing remains experimental, but its implications are profound. Consciousness no longer appears as a fixed gift, but as a narrative open to revision. Science is no longer just studying it, it's beginning to rewrite it. For centuries, science has attempted to uncover how the brain gives rise to consciousness. We've mapped brain regions, recorded electrical impulses, and identified neural correlations. But despite decades of effort, one uncomfortable truth remains. There is no scientific theory that explains how physical processes become experience. As early as the 19th century, physiologist Thomas Huxley acknowledged this with brutal honesty. The connection between mental states and nervous system states is, and likely always will be, inexplicable. John Tyndall was even more direct. No advancement in physics or biology had ever managed to reduce the taste of a strawberry, the pain of a loss, or the love for a child to mere material processes. This conundrum has come to be known as the hard problem of consciousness. Unlike other scientific challenges, it's not a matter of gathering more data. It is a conceptual chasm. Between matter and experience, there is a rupture. You can measure the brain activity associated with fear, but that won't reveal why it feels like fear. the subjective aspect, the what it's like, remains an absolute mystery. This has led some thinkers to revisit ancient philosophical ideas, suggesting that consciousness might be an irreducible feature of reality, not unlike gravity or electromagnetism. Rather than being an emergent property of complex brains, it could be intrinsic to the very fabric of existence. If this is true, our scientific tools may need to evolve, not just in precision, but in kind. A ruler cannot measure warmth. A microscope cannot detect meaning. To truly approach consciousness, we might need methods as radical as the mystery itself. Tools built not only to observe, but to reflect. Some scientists suggest that perhaps consciousness isn't a byproduct of the brain, but a fundamental element of the universe, something as basic as space or time. In this view, the brain doesn't produce consciousness. It channels, organizes, or interprets it. Consciousness becomes the foundational layer, not a consequence. From this angle, the hard problem doesn't disappear by being solved. It dissolves by being reframed. Consciousness no longer needs to arise from matter. Rather, matter itself might be a construct within a wider consciousness. Such a shift challenges the foundations of traditional science, but perhaps it also liberates them. If space-time and particles cannot contain experience, maybe the flaw lies in the framework, not the phenomenon. The mystery remains, but now the ground may be ready for a science that does more than measure, one that begins to understand the unfathomable depths of conscious being. And that concludes our video. If you enjoyed the content as much as we did, don't forget to subscribe so you don't miss a single episode. Leave a comment below. We'd love to hear your feedback and suggestions for future videos. And don't forget to turn on notifications to stay up to date with all our updates. Thanks for being part of our community. See you in the next video.